Hello and welcome to Friday's quiz. Question number 1 reads mass, length, and time are all SI-based quantities. State 2 other SI-based quantities. You have 30 seconds remaining. All right, we'll come back to that question shortly. Moving right along to question number 2A. Let's define speed and velocity and use these definitions to explain why one of these quantities is a scalar and the other is a vector. You have 200 seconds. 2 times 10 to the 2 seconds. Forty-five seconds remaining. All right, that's time, but does anybody need a little bit more time on this one? Raise your hand, take your time. How about everybody following along on YouTube? How are you all doing? Leave it down in the comments below. All right, that's time on that question. That's time. We'll come back to that one in a moment. Moving right along, question 3A reads, force is a vector quantity. State 3 other vector quantities. You've got 60 seconds. Starting like 30 seconds ago, so hurry up. No, I'm just kidding. 50 full seconds. All right, hopefully you're able to find 3 vector quantities other than force. If not, don't worry about it. We'll go over that shortly. Move on to the next one. Define force. Define force. We have 90 seconds starting now. $45 seconds remaining. All right, that's time on that one. Question number 2, which I think is actually question 5. So number it that way. What is the vertical component of this displacement vector? Stop the quiz.
Calculator check.
Who's got him? Let's see it. Calculator check. You didn't bring a calculator. Okay. So, calculator 1, 2. Who got extra calculators? I think 2 of you. Got extra ones? I want to do a colleague. Why don't you just phone calculator? Okay, this is a regular calculator. Just for the purpose of the calculator check, that's like 50 points. Like when I go around, I'm like, check, check. Help your colleagues out if they're like after you've already got credit, you know what I mean, and then we'll figure it out after that. I'm just saying that you're out of 50 for calculator check. That'll happen from time to time. Okay, calculator check. You should work out every day. Every day we're calculator, whether it's quiz day or not. All right, so everybody's got a calculator or has the ability to have a calculator in front of them, right? You got, if we're checking, yes, everyone in this row has their calculator. Let me now look this way. And by the time, oh yeah, the calculator there too. Good. And it seems like 100% of the students in class have calculators. Well done. I think it's 50. Let's go back. We need the calculator on this one, right? All right, let's go over these solutions in reverse order. So maybe by now you've had time to solve this. Maybe you're like, hey, just give us a few more seconds. Come on, you don't really have enough time yet. So that reminds me of a funny story. It's not so much funny as it is long and boring. It all started long ago. If this is 5 kilometers, thusly going at 37 degrees relative to, I guess, like the negative x-axis, like this way, and we want the vertical component, I'll sketch it like that. Maybe a rough sketch in your journal to sort of, work with this. And you say, well, if that's horizontal and that's vertical, that's 90 degrees. I'll call this the hypotenuse of a right triangle. And I want a function that can relate the thing I want to know, the side opposite, that's vertical, right? It's opposite this angle. So I want a function that relates the opposite to the hypotenuse. And that's the O in, so in SOHCAHTOA, right? So that's that mnemonic device that helps us remember what ratio of sides correspond to what trig function. So here we want to know the side opposite. We do know the hypotenuse. And so it's the sine function that's going to be helpful. The sine of the angle, always the function of the angle. Sine of the angle equals the side opposite, the thing I want to know, let's call it x, throw back to math class. And then over the hypotenuse, 5 kilometers. Keep the units because you get in a good habit of, oh yeah, all my answers are in kilometers, right? Multiply both sides by 5. And you say, oh, that's why the calculator, right? So if I happen to have memorized the sine of 37 degrees, it's what's 0.6018150023, something like that. And we'll multiply that by 5. I'll do that in my head, 3. So you should have got 3 for that. Like, hey, wait a minute. This is a 3, 4, 5 right triangle, right? We know that 3 squared plus 4 squared is 25. Everybody saw that connection too. Well done, everybody. People that use the cosine function then would have got this incorrect answer, right? They would have, oh, it's the adjacent. So if you solve for that one, there's that answer right there. Don't make that mistake. Nobody in here did. All right. Give yourself feedback. If you ended up solving this for choice A, 1 out of 1. If you didn't get it, 0 out of 1 on the first one. Yeah. The 3 is the answer to this. So if you take the sine of 37 degrees in your calculator and then multiply it by 5, you should get 3.00907. It's about 3. And this is just multiplying both sides by 5, right? So this, once you have it sort of like this, that's your only unknown. So this x is this solving for x there. And that's what they want, right? They want the vertical component. So here's the displacement vector saying I went 5 kilometers this way. That means I really went over 4, right? If this is like, say, north, I went west 4 and then north 3. And I ended up 5 kilometers, 37 degrees, that way. Any questions on this one, whether you earn the mark or not? Anybody have a question about your working, whether or not it would earn the mark or not? So score that for me. And let's move along to this one. Define force. There's only one thing you could have said here, class. Lots of things that are correct to say about force, but you should have said rate of change of momentum. Rate of change of momentum. And judging by the quiet celebration in the class, it sounds like a lot of people earned that one. Rate of change of momentum. The people that didn't were like, well, how did everybody know that? It was like one day where we really focused on it. It's like, this is the way to define force. I even sort of said it. And if you're ever quizzed on that, right, then make sure you have that. And so add that into your notes if you didn't already have that. That is the definition of force, the rate of change of momentum. And let's put it in sort of equation form. The change in momentum over the change in time. These rates of change like times in the denominator. So we'll use this a lot. F equals ma is a special case of this. Let me show you that really quickly. So in general, the rate of change of momentum is force. What is the change in momentum? Momentum is mass times velocity. Okay, so the change in momentum is like mass times the final velocity minus mass times the initial velocity. We'll use the letter U for initial velocity because it comes before V alphabetically, over the change in time. If mass is constant, if the mass of the object isn't changing, like a ball, a physics sphere rolling down a ramp, okay, the mass didn't change. We could factor that out, right? And we'd have V minus U over T. And next week, this is how we'll define acceleration. So V minus U over T is acceleration. And so this becomes F equals ma when mass is constant. This is a special case of this more general definition. So this is the way to define it. It's good to know F equals ma. When in doubt, F equals ma it out in this class. Okay, it's a very important equation, but it's just a special case of this more general. Okay. Sometimes the mass isn't constant, like my favorite, rocket science, continuously variable mass, right? You need some calculus there, deal with that, because the mass of a rocket's always changing because it's, you know, generating thrust from exhaust gases, but you know, so it's always changing its mass. Or a snowball rolling down a hill, right? It's picking up mass all the time. So there are situations where, you know, we can't use this, but a lot of times mass does stay the same, so we can. Hey, bonus information going into our quiz working here. This is a 1-mark question. You either got it or you didn't. So it's like, it's okay if you didn't get it. Just get the note down and say, I'll never miss that one again. Force is always defined as the rate of change of momentum. Very important to know that. And yeah, we covered it like one day. It's not really something we emphasize. So if you want to give yourself half a mark, because like, well, I wrote it down now, give yourself half a mark. You know, we'll be flexible here. You know, I'm not an unreasonable person. All right, vector quantities. You needed to come up with 3 of them. You could have said a lot of things. Maybe a lot of people said, let's put some like typical ones up here. So we've covered what vectors? Displacement. Hopefully everybody got displacement down, velocity. Right, those are the 2 that we actually defined like in our journal as vector quantities. So those would have been 2. And then we've gone over a number of practice problems where it's like, hey, we'll study this later, but sort of we mentioned them in passing. So probably momentum is another one that maybe some people got there. You could have said acceleration. That's a vector. Did anybody put down impulse? Weight, good. Well, weight is a force. Let's credit weight, okay? Weight is the force due to gravity. So tension, that's another force. So we have force is so important. They have different types of forces like tension, weight, friction. Those are all types of forces. So they're all vectors, that's true. You know what, if you said weight, give yourself a +1 on that. That's well done because weight is indeed a vector, okay, but it is a force. I don't know if they credit that if you're sitting, you know, for this paper, but I'm going to credit it with a +1 because that's well done, class. So good job on weight there. Anybody know the equation for weight while we're doing some bonus physics in our? Yeah, if you said weight equals mg, or if you want to take that note down right now and say this W stands for weight, and it is the force due to gravity. It's how much gravity is influencing your mass. Good job on that. Did anybody put anything else down that they're not sure is that a vector or not? You need me to assess that? How about you, YouTube? Leave it down in the comments below. I see that in my lifetime, I'll try to answer it. But if you're watching this hundreds of years in the future, you know, somebody else will get back to you. right, I think those are good answers there as well. We want to define speed and velocity and use the definitions to explain why one is a scalar and one is a vector. So speed is just distance over time, and is scalar because distance is scalar. Could have said that. There's lots of things you could have said that's perhaps correct here, but you should have said that the definition of velocity is the rate of change of displacement. Get in the habit of defining things as rates of change if they are rate of change of displacement. And so that one's the vector, velocity, vector. Rate of change of displacement, so we said like velocity is displacement over time. Again, time in the denominator, it's like the displacement is changing as a function of time. This is why the slope of a displacement time graph gives velocity, right? We're plotting displacement in meters, time in seconds, and if we do rise in meters over run in seconds, meters per second of velocity, right? So if it's a steep line, it's going very fast, it's covering a lot of meters in a little bit of time. If it's a shallower slope, it's covering, less meters in the same amount of time. And a horizontal line, right? The slope is 0, so that's 0 meters per second. All right. The rate of change of displacement, velocity is the vector because displacement is a vector. You could also say, if you said something like velocity has direction, velocity is speed plus direction. That's a pretty good thing, I think, to say too. It's like, speed is just the magnitude only. Velocity has direction. That's really getting to the key idea of like why, it's really answering this, explain why one of these quantities is a scalar. So we probably should have said something like, because displacement is a vector, has direction. Velocity has direction, something like that. That, I think, is a keynote. Even if you didn't say that, but you said something else that's basically correct, I would sort of add that in explicitly to remind yourself that that's a key important idea with vectors. This is why we do like the resolving vectors. The essential question today is about that. If the quantity has a direction, then we can sort of calculate, a little bit more in terms of the mathematics with the geometry and trigonometry to sort of predict, okay, in this direction is where the force is acting. That's where it will accelerate. This is where it's going to be. So it gives us sort of more information. Speed is just the magnitude. Velocity is the magnitude speed plus the direction. So that's a good way to sort of answer that as well. All right. Anybody have a question about what they put down, whether or not it would earn these 2 marks? It's like if you, mix them up like, oh, I thought speed was the vector, then you probably got 0 out of 2. But if you got like, yeah, I pretty well got that, kind of use your judgment to say whether or not you feel like you would earn both of those marks, or it's 1 or. They don't really award half marks, but you can in this class if you're like, I feel like I earned like half a mark. Question. 3A, 3 marks, 1 for each one of them. Unless you got, I think, a +1 for the weight. I say you might have got 4 out of 3 on that one. Good question there. All right, and then working our way backwards here, we had this one. Mass, length, and time are all SI-based quantities. We want 2 other SI-based quantities. And so this is the difference really between units and quantities, okay? We have mnemonic devices to help remember the base units. So you shouldn't have listed any of those words, right? Those are all the units. We want the things that they measure. And they already took like 3 of them from us. And so there should be 4 possible answers. You only had to come up with 2 of them. They would have been what? Temperature would have been 1. Amount of substance would have been 1 for moles. You could have said that. Current is the base quantity, right? Measured in amps. And what's the last one there? Luminous intensity, right? They already took distance with this. So if you put distance down, just say like, oh, okay, that's synonymous with length. And so that's one of the ones they already sort of, they already called it. You would have had to said 2 of these 4. Didn't they put all 4 down? Luminosity, luminous intensity, we'll credit that. Luminosity. No, because candela is the unit, right? And so that really is the sort of paying close attention to the difference between quantities and units. And so the candela is the unit that measures what? Luminosity or luminous intensity. So candela is incorrect. Did any put 3 out of the 4? Because it's wrong. It says state 2, follow directions. Come on. No, I'm just kidding. I mean, would they be harsh about that? It's like, well, they put extra answers, they didn't follow directions, so they count you, like, you know, mark you against that. I think if it's correct, they wouldn't count it against you, but. Then it's like, oh, let's do my working over here, but these are the answers I recorded. So yeah, that could be like, you know, you have them all 4 listed, and then you chose your favorite 2 out of that. I don't know. All right, good warm up. You guys ready for the quiz? All right, YouTube. Go ahead and report your answers down in the comments.